In our last video where we're introducing some of the basics of Python coding, the last topic we want to discuss is that of a pipeline. So a pipeline allows us to apply functions or steps in a particular order. We're going to be using pipelines later on when we do machine learning, and it helps us pre-process data, so some data engineering, that extraction, transform, and load. We also use it in machine learning where we're going to apply multiple steps, standardize the data, fit one model, fit another model, and so on. So you can see an example of this here on the right. So this code here would be a pipeline, and we'll look in a moment at a machine learning one, but here's a very basic pipeline. So here we're going to need a couple packages. We're going to import pandas and call it PD. This is going to allow us to create a table, which is called a data frame. And so we first import the data. So here we have some forecasted values. We're going to forecast here the number of occurrences. And so we have integers, and that forecast goes 20, 15, 17, 18, 9, 17, 25, and 23. All of these are forecasted values. We want to first convert it into a table. So this is what pd.dataframe is. It uses pandas, which we're calling as PD, and it then uses the command data frame and applies it to the forecast. So it's going to take that forecasted information, which you can see is listed as a dictionary because you see the curly brackets. The variable name is X and the values are 20, 15, 17, and so on. So it's going to take this dictionary here and it is going to turn it into a table called a data frame. And we'll name that data frame DF. All right, we now have it in the proper formatting to do a pipeline. So a pipeline is going to apply functions or steps in a particular order. So we need a couple functions. We're going to define a function called naive_error. We want to measure the forecasting error, how far off the forecast was from, let's say, a naive approach where we have where the actual value here is just a single number. So we have a function that says, give me these forecasted values X and compare it to some naive number. So it's going to take the naive number, which we can provide later, and it's going to subtract each of the forecasts from that number. Okay. Then we're going to create a second function where we're going to define mean absolute deviation, called MAD, and it's going to take the error and it's going to find the absolute value, so it's going to get rid of the negatives, and then it's going to calculate from there the average of the error. So how far on average is it off from the actual number, but we're only considering the distance, not whether it's higher or lower. So we're defining mean absolute deviation as taking this forecasted error, find the absolute value, and return the average of that. So y equals absolute value of X, and then it's going to take y.mean, so it's going to take the average of the y, and axis equals 0 simply means that it's going to take the average of the numbers and in the column. And it's going to return that. So we're going to get a single average for how far on average are we from that naive estimate when we do these steps. So we want to do our pipeline. So we're going to apply our pipeline to our data frame. The data frame we call DF. So we do df.pipe. And then we call the first function. So it's naive_error. And it's going to apply it to the data frame DF. So we simply need to give it any other variable values. So here we need to give it the naive number. And so we're going to compare our forecasts to the number 20. So what it's going to do when we do our pipeline is it's first going to calculate the error by taking 20 minus all of those forecasted numbers. Then we do .pipe. So the next step in the pipeline is to take that information that it calculates, that naive minus the forecasted, and then it's going to, from there, find the absolute value and then find the average. So we can take a look at how that works inside our Python code. And just a reminder, that we are working through this Intro to Python, that workbook you can find at drstephpowers.github.io/BIA. Go in there, open it up in GitHub, click on the Google Colab button, log into Google Drive, and make sure that you save a copy. And then, of course, any changes you make sure you hit save as well. It will not auto save. All right, so back to our workbook. All right, here's our pipeline. So we're going to import pandas as PD. So this allows us to create that data frame or table. And we're going to import statistics. That's needed here because the mean, to find the average, is a command in the statistics package. So I need to import the statistics package. We have created our forecast here, as we said, as a dictionary, where X is the variable and 20, 15, 17, 18, 9 are the values for that variable. We convert it into a data frame by doing the PD package, the pandas, the command data frame, and applying it to our forecast. When you do that, and we type in DF, you'll see that it has turned the information into a table. So here X is the name of the column, and here are our values. What you see on the left are the index numbers. Remember, indexes start with 0 as they go up. Now to do a pipeline, we're going to need our functions. So here we're going to define the naive error as the forecasted number, like 23, compared to some naive value, which we can provide in the future. So it's going to return naive minus X. So if we say the naive is 20, 20 minus 23, it'll return a -3. So we're going to enter in that function. And then here's our function for calculating mean absolute deviation. It's going to take these new values that have been created. It's going to find the absolute value of them, and it's going to find the average of them. So we'll put it into the system. And then we run our pipeline. So we are doing the pipeline on the table called DF. That's this table right here. It is first going to do the function naive underscore error, and it's going to use as X that DF table. Then it needs on the other part of the function, which is naive. So we're going to say, let's suppose that the naive estimate is 20. So compare the forecast to the number 20. Then once that is complete, then the pipeline continues on, and it's going to take the results of that, so the naive minus the forecast, the error, and it's going to find the absolute value and the average, and that's this piece right here. So we could run this pipeline, and what we get here is we get that the mean absolute deviation is 4. So on average, if the naive estimate is 20 and our actual number, or our forecasted numbers ranged from, what do we got, 9 here to 25, then on average, the forecast is 4 away from 20. So if we're averaging the distance away from that 20. So we can put into the pipeline these different steps in the process. Now, to be honest, when we're going to do a measurement error and mean absolute deviation later, we're not going to use a pipeline. And that's because this multi-step process can be accomplished with a single function. We could put into this function, we could define MAD and have it first find the error, then find the absolute value, then find the average. There's really no reason to have a pipeline here, but we're just trying to show you kind of a simple example. Where we will use pipelines is when we get to packages that are already pre-built. So here, for example, this is a pipeline where we are using k-means clustering, and we are using single value decomposition to help in the process. So these already exist. It's not us defining the function. There are already packages in Python that we get from sklearn.python. We'll import the package that makes a pipeline. We'll also import from sklearn these different packages for part of our machine learning process, which means when we go to make a pipeline using these, we simply call the command make pipeline, and then we call in the packages in the order we want them applied. And then we can do things to the entire pipeline. We can fit, we can predict, And so we're going to use that. But in terms of the more simple pipelines where we are defining a process or a step and then calling each of those, oftentimes it's just easier to put it all into one function and then just do the function as opposed to building the pipelines themselves. So let's give it a try before we end here. Let's define a function that adds 2 to each item in the data frame, and then define a function that multiplies by 2 to each item in the data frame, and then let's combine it into a pipeline. So for example, let's suppose here that we have our data. Here's it in dictionary form. Here's our x variable. Here are the values for our x. And our first step is going to turn it into a data frame. So you do want to make sure that we have, that we import, ooh, wrong spot, that we import pandas if you haven't already. If you've done it already earlier in the worksheet and you've run it, then you don't have to do it again. But if you're doing this from scratch, we always want to make sure we put in the appropriate functions. So we import pandas as PD. We'll load in our data. We convert our data to a table, and we can see the table here. Okay, now pause the video to allow yourself time to create a function that adds 2 to each item in the data frame, and then define a function that multiplies by 2 to each, and then combine them into the pipeline. So these can be very simple. So we can define add 2 as give us the value of x and then return x plus 2. And we can define multiply times 2. You can call it whatever you want. Multiply 2 and provide a value of x. And then return x times 2. Times 2. So very simple definitions here. And then what we want to do is we want to create our pipeline. So it's going to look just like the previous. So here we had df.pipe and then the name of the functions and the order we want to do them. So here we have, again, df, because that's the name of our table. If you've named it something else, monster or whatever, then it's monster.pipe. So whatever the name of your table is, and then it's going to be the name of your first function. So here we're going to add 2. Notice that this function only had one variable, just x, so we don't have a comma anything here. And then we have multiply times 2, mult2. Okay. So we can run this pipeline. And what we get, if we started out here with the number 3, it adds 2 to 3, so it gets 5, and then multiplies times 2, and we get 10. And you can see here's 5, it adds 2, so we get 7, and then it times 2, and you get 14. So you can see here with our pipeline, we have added 2, and then we have multiplied times 2 to get our new output.